at rotations now. And I think there's one thing that needs a correction in the notes here. And that is this coordinate on the bottom of your graph. It should be B negative A. There we go. So the rules for rotations are that rotations always go counterclockwise unless they tell you otherwise. If they give you a negative degree amount, that would be telling you to go clockwise. What you would have to do is subtract that from 360 to get the direction and the amount that you're going to go in counterclockwise. And it's the same if they say go clockwise 90, then you want to go counterclockwise 270. Just to show you like on this little graph. So like if I had point AB and I wanted to go 90 clockwise, that would be here. That's the same as going counterclockwise 270. And since all of our rules are related to the counterclockwise direction, we need to take what we're given or what we're asked to do, and we need to find out how much to go counterclockwise for that. If you're rotating 90 degrees, and I have these written in terms of A and B, but you could write them in terms of X and Y, do know that A and B are representing your original point. They may not be both positive values at the start. When I write a negative sign in the rule, that means a sign change. It doesn't mean that you're always going to have a negative value. How I memorize these is I memorize the 90 and the 270 together. For the rule of 90, you're switching the places for your A and your B, or your X and your Y. And your new first one changes sign. For the 270, and this is why I memorize them together, this one switches as well. The A and the B switch places, and the new second one changes sign. And so the way I remember it is that the 90 and the 270, the X and Y values switch places for both of those. And 90 is less than 270, so with the 90, the new first one changes sign. And with the 270, the new second one changes sign. The 180 degree rotation rule is just that you change the signs. You are not switching the X and Y, you're just changing the sign on the numbers that you have at the beginning. So if it was negative, it's now positive. If it was positive, it's now negative. We're going to practice a couple of these. All it is write the rule, apply the rule, graph the points. So this first question, we want to rotate 90 degrees. So what I do first is I make a note about what the rule is for the 90 degree rotation. And we can write it in terms of X and Y or A and B, whatever you want. But they switch places, and the new first changes sign. So we're going to switch the places and change the sign. And this is like original A and original B. So what I do to apply this rule is I write my new points down. So A, I switch the numbers in order, and I change the sign on the new first. So I do it as a two-step process. So this will be A prime. Almost forgot my prime. B prime, switch the order, change the sign of the new first. C prime, switch the order, change the sign of the new first. So just thinking about that process as like a two-step thing, you write your new points. It says to graph the polygon and its image. So a polygon is just a figure like a triangle, a rectangle, a pentagon, a hexagon. Those are polygons. They're formed by straight sides that meet at points called vertices. Just your basic shapes are your polygons. We all are also going to graph the image. So we're graphing the original and the new figures on the same graph grid. If it says to do this, then you will need to actually do the graphing to get full credit for the problem. So A is at the point 1, negative 2. B is at the point 4, negative 1. And C is at the point 3, negative 4. So here is our original figure for ABC. Now let's graph the new one. A prime is at 2, 1. B prime is at 1, 4. C prime is at 4, 3. Graph the new. You can use your graph, and if you connect your original or one of your original points with the vertex or the origin, and connect the origin with your new point for the same letter, and look and think about how you are trying to go counterclockwise, which is like a left turn. And we can see that this appears to be 90 degrees, and we could check the slope of these segments, and we could verify that they are perpendicular to each other and do give us a 90-degree turn. And that's how you do a rotation. Let's look at another one. We are rotating quadrilateral ABCD about 0.27 or about 270 degrees. Man, about the origin. Struggling to read. All of our rotation rules are based off of the origin. 270-degree turn is going to switch your X and Y, or your A and your B, and your new second will change sign. So the rule for 270, B negative A. Going to list my new points. So my A prime, if I switch the numbers, they would be -2, -1, and now change the new second value, the sign of it. B prime, switch your X and Y, change your new Y value. C prime, switch your X and Y, change your new Y value. And D prime, switch your X and Y, change your new Y value. So we've got our points now, and we want to graph the original and the new. So graphing the original at -1, -2, there's your A. B is at 2, 1. C is at 3, -1. And D is at 1, -3. And it's A, B, C, D, so you connect the dots in a way where you're forming A to B, B to C, C to D, and then connecting back D and A. So we have our quadrilateral there, and our new one. A prime is at -2, 1. B prime is at 1, -2. C prime is at -1, -3. And D prime is at -3, -1. Connecting the dots. I feel like I have an extra. -1, -3. Oh, that's C prime, my label. I thought it was a point for a second. C prime, there we go. A to B, B to C, C to D, D to A. All right, there we've got our figure, and they look kind of weird because they're like crossing through each other. I'm going to choose a point to connect with the origin. I'm going to use A, connecting point A to the origin, and then the origin to A prime. It looks like a 90 degrees, but keep in mind that we want to start at A and go to A prime. So it's really going like this. And so this is a 90 degree, but that means that this is a 270 degree angle in the counterclockwise direction. And you can use patty paper and check your rotations and make sure that your shapes are still congruent, because the term rigid transformation that we looked at in the translation video is where it maintains congruence where your new and your original are congruent to each other, and that works for a translation, a reflection, and a rotation. So it works for all three of these where they're still congruent. So using that patty paper can help you to check that you have done this correctly. And using graphing from an original to the origin to the new to check that your angle appears to be the right angle of rotation. And those are our rotations samples.